Hi there, science fans. Bill Nye here, and boy, have I got a treat for you. We're about to embark on a thrilling adventure, exploring the wonders of science right from your kitchen table. You see, science isn't just about textbooks and labs, it's all around us, waiting to be discovered. And the best part? You don't need fancy equipment or a lab coat to unlock its secrets. In this series, we'll be diving into the top 10 science experiments you can easily do at home with everyday materials. We'll be creating erupting volcanoes, building rainbow towers and glasses, and even whipping up some elephant toothpaste. So, gather your curiosity, grab your safety goggles, and get ready to unleash your inner scientist. Let's get experimenting.
All right, science explorers, for our first experiment, we're going to recreate the explosive power of a volcano. Don't worry, we won't need to travel to any active volcanoes for this. To get started, we need a few common household items. First up, grab some baking soda, the same stuff you use to make cookies rise. You'll also need some vinegar, the tangy liquid that makes pickles so delicious. Next, we need some dish soap, the kind you use to wash your dishes. And for an extra dose of volcanic fun, let's add some food coloring. Finally, find a container to be our volcano's base. A small bowl or even a plastic cup will work perfectly. Now that we've got our scientific ingredients prepped and ready, let's move on to building our very own erupting volcano. Now comes the fun part. Start by shaping your volcano around your container. You can use clay, Play-Doh, or even just build a cone out of construction paper. Remember, the shape of your volcano is up to you. Once your volcano is ready, it's time to add our ingredients. Pour a generous amount of baking soda into the container inside your volcano. Now, add a few drops of dish soap to the baking soda. This will make our eruption extra bubbly. Now, for the grand finale. Carefully pour vinegar into the container with the baking soda and dish soap mixture. Watch in amazement as your volcano erupts with a foamy, colorful lava flow. What you're witnessing is a classic chemical reaction between the baking soda, which is a base, and the vinegar, which is an acid. When they mix, they create carbon dioxide gas, causing all those exciting bubbles.
After that explosive experiment, let's switch gears and create something a little more colorful and a whole lot sweeter. Get ready to build a mesmerizing rainbow right in a glass. For this experiment, we'll need some sugar, the same stuff you use to sweeten your lemonade. You'll also need water, the essential ingredient for life and for making our rainbow layers. To paint our rainbow, we'll need some food coloring. Feel free to use as many colors as you like. And finally, grab a spoon for stirring up our colorful concoctions. Now that we've gathered our rainbow-making essentials, let's dive into the fascinating science of density. Here's where the real magic happens. We're going to create different sugar solutions, each with its own unique density. Density is how much stuff is packed into a certain space. Start by adding different amounts of sugar to each glass of water. For example, one glass might have 1 tablespoon of sugar, the next 2 tablespoons, and so on. Stir each glass well until the sugar dissolves. Now, add a few drops of food coloring to each glass, creating a rainbow of colors. Remember, the more sugar you add, the denser the solution will be. Now, here's the really cool part. Carefully layer the solutions in a tall glass, starting with the densest, the one with the most sugar, at the bottom. You can use a spoon or a dropper to help you create those distinct layers. And voila! You've created a stunning rainbow in a glass. The different densities of the sugar solutions prevent them from mixing, allowing the colors to stay separated. It's like magic, but it's really science.
Hey there, science fans! Get ready for an experiment that's going to make your toothpaste jealous. We're about to create a reaction so big, so foamy, it'll look like an elephant's worth of toothpaste. Remember, safety first? Grab your safety goggles and let's get started. You'll need hydrogen peroxide, yeast, dish soap, food coloring, and a container. First, pour half a cup of hydrogen peroxide into the container. Add a big squirt of dish soap and a few drops of food coloring. In a separate cup, mix a tablespoon of yeast with warm water. Pour the yeast mixture into the container and stand back. Watch as the mixture foams up and erupts like a volcano.
So, what's the science behind this foamy explosion? It's all thanks to a chemical reaction. Yeast acts as a catalyst, speeding up the breakdown of hydrogen peroxide. The oxygen gas gets trapped by the dish soap, creating tons of tiny bubbles that make up the foam.
Have you ever wanted to send secret messages like a real-life spy? Well, get ready to unlock the power of invisibility with this fun and easy experiment. It's time to ditch those fancy invisible ink pens and make our own with some simple household ingredients. All you need for this experiment is a lemon, a cotton swab, some paper, and a heat source. Don't worry, it doesn't have to be fancy. Even a light bulb will do the trick. First, squeeze some lemon juice into a small bowl. This is going to be our invisible ink. Now, dip your cotton swab into the lemon juice and start writing your secret message on the paper. You can write words, draw pictures, or even create your own secret code. Once you're done, let the paper dry completely. The message will seem to disappear, but don't worry, it's still there, just hiding. To reveal your secret message, simply hold the paper up to your heat source, being very careful not to get too close. As the heat gently warms the paper, your invisible message will magically appear before your eyes. It's like science magic.
So, how does this invisible ink work? It all comes down to a chemical process called oxidation. Lemon juice contains a special ingredient called citric acid, which is a weak acid. When you apply heat to the paper, the citric acid in the lemon juice reacts with the oxygen in the air. This reaction causes the citric acid to oxidize, which means it changes its chemical structure and turns brown. The paper itself also contains various organic compounds. When heated, these compounds break down and release carbon. The carbon then reacts with the oxidized citric acid, making the writing visible. This experiment is a great example of how chemistry can be used to create fun and interesting effects. It's also a reminder that there's always more to discover about the world around us, even in the most ordinary things.
Get ready to dive into a world where liquids act like solids and solids act like liquids with Oobleck. Named after a gooey substance in a Dr. Seuss book, it's just as weird and wonderful. For this experiment, all you need is some cornstarch, water, and a bowl. Start by adding 1 cup of cornstarch to the bowl. Slowly add half a cup of water, stirring constantly. The mixture should be thick and gooey, but not too watery. Now comes the fun part. Try picking up the Oobleck in your hand and squeezing it. It feels solid, right? But as soon as you release the pressure, it oozes back into a liquid.
Oobleck is a non-Newtonian fluid, meaning it doesn't follow the usual rules of how liquids behave. When you apply pressure, the cornstarch particles get closer together, making it feel solid. Release the pressure and it flows back into a liquid state. It's like a magic trick thanks to science. Hey there, science fans! Get ready to illuminate your inner scientist because we're about to create our very own lava lamps. First, grab a clean, empty bottle or jar and fill it 3/4 full with vegetable oil. Slowly pour water into the container, leaving a little space at the top. Add a few drops of your favorite food coloring. Finally, drop an Alka-Seltzer tablet into the mix and watch the show begin. The gas bubbles rise, carrying the colored water, creating a mesmerizing lava lamp effect. Remember to ask a responsible adult for help and follow safety precautions. Stay tuned for our next experiment, where we'll blast off with a DIY balloon rocket. Welcome back, Space Cadets. Today we're exploring Newton's third law with a balloon rocket. Gather your materials: a balloon, string, straw, and tape. Thread the string through the straw and tie it to a sturdy object. Inflate the balloon, but don't tie it off. Secure the balloon to the straw with tape. Position the balloon so the open end faces away from the string. Release the balloon and watch it propel forward. The escaping air creates an action force, propelling the rocket. Experiment with different sizes and lengths to see the effects. Next, we'll witness the magic of capillary action as we make water walk. Welcome back, science enthusiasts! Today we're going to witness the incredible power of capillary action. Now, you might be thinking, capillary what? Well, it's a fancy way of saying that water can move in mysterious ways, even defying gravity. For this experiment, you'll need some paper towels, water, and a few different colors of food coloring. Now let's dive into this watery adventure. First, grab 3 clear glasses and fill them with water. Leave 1 glass empty. Next, add a few drops of red food coloring to the first glass, blue to the second, and yellow to the third. Now, we're going to connect these glasses using our paper towels. Fold 2 paper towels lengthwise to create long strips. Then, carefully drape one end of the first paper towel strip into the red water and the other end into the empty glass. Repeat this process with the second paper towel, placing one end in the blue water and the other end in the now partially red glass. What do you think will happen? Will the colors stay put, or will they embark on a colorful journey? Well, thanks to capillary action, we're in for a treat. You see, water molecules are naturally attracted to each other, like little magnets. This attraction is called cohesion. But that's not all. Water molecules are also attracted to other materials, like the fibers in our paper towels. This attraction is called adhesion. Capillary action occurs when the adhesive forces are stronger than the cohesive forces. In our experiment, the water molecules are more attracted to the paper towel fibers than they are to each other. This causes the water to climb up the paper towel, defying gravity. As the colored water travels up the paper towels, it will eventually reach the empty glass, creating a stunning visual display of capillary action. Observe how the colors mix, creating new hues as they travel. It's a fantastic demonstration of how water can move in unexpected ways. Stay tuned for more amazing science experiments. Hey there, science fans! Get ready for a colorful experiment that'll make you say, "Taste the rainbow." Well, maybe not literally, but you'll definitely see it. We're making a Skittles Rainbow, and it's all about the power of solubility and diffusion. First things first, grab a plate and arrange your Skittles in a circle around the edge. You can get creative with the colors and make patterns, or keep it classic with a rainbow order. Remember, science is all about exploration. Now for the magic ingredient, warm water. Carefully pour the water into the center of the plate, making sure it reaches the base of all the Skittles. But hey, easy does it. We don't want to drown our Skittles, just give them a nice little bath. Keep your eyes peeled. You'll start to see those vibrant Skittles colors spreading towards the center of the plate. It's like a slow-motion fireworks show, but with candy. This, my friends, is the beauty of science in action. So, what's going on here? Well, Skittles are coated with sugar and food coloring. And guess what? Sugar loves water. When the warm water touches the Skittles, it dissolves the sugar and color coating. This process is called dissolving or solubility. Think of it like this. The water molecules are like tiny magnets, pulling the sugar molecules away from the Skittles and spreading them out. But wait, there's more. As the colored sugar water spreads, it bumps into other colors, creating a beautiful blend of hues. This movement of molecules from an area of high concentration to low concentration is called diffusion. Pretty cool, right? We just witnessed 2 important scientific principles, solubility and diffusion. And all it took was a little candy and water. Get ready to be charged up with excitement as we explore the electrifying world of static electricity. It's all about those tiny particles called electrons and how they can make things attract or repel each other. For this experiment, all you need is a balloon and some small pieces of paper. You can even try this with your hair. But first, let's talk about what static electricity is. You see, everything around us is made up of atoms, and atoms have these tiny particles called electrons. Electrons have a negative charge. Rubbing certain materials together, like the balloon in your hair, can cause electrons to transfer from one object to another. This transfer of electrons creates an imbalance of charges. The object that gains electrons becomes negatively charged, and the object that loses electrons becomes positively charged. And that, my friends, is how static electricity is born. Now here's where the fun begins. Once you've rubbed that balloon on your hair, hold it close to the small pieces of paper. Watch as the paper jumps up and sticks to the balloon. That's the power of static electricity. The negatively charged balloon attracts the positively charged particles in the paper, causing them to stick together. It's like magic, but with science. You can even try this with other objects around your house, like a salt shaker or a plastic comb. Remember that opposites attract when it comes to static electricity. The bigger the difference in charge between 2 objects, the stronger the attraction or repulsion will be. So go ahead, explore the electrifying world of static electricity and see what kind of shocking discoveries you can make. Well, there you have it, science fans. 10 amazing science experiments you can do at home using everyday materials. We've explored volcanoes, rainbows, elephant toothpaste, and even the power of static electricity. Remember, science is everywhere and it's for everyone. So don't be afraid to get your hands dirty, make some messes, and most importantly, have fun while you're learning. If you enjoyed these experiments, be sure to give this video a thumbs up. Subscribe to Tech Thrills for more awesome science content, and share it with your friends. And hey, let us know in the comments which experiment was your favorite and what other science mysteries you'd like us to explore next. Keep on experimenting and stay curious.